In problem 23, we're going to be working with compound inequalities. Compound inequalities contain the words and or. We'll start by focusing on and. And inequalities must fit both criteria. I'm going to solve both inequalities and graph them in different colors. I'll start with the first. 6x minus 3 is less than 9. So, if we add 3 to both sides, 6x is less than 12. Divide both sides by 6, and x is less than 2. The next inequality, I am going to subtract 9 from both sides. And we get 2x is greater than or equal to a negative 6. Divide both sides by 2, and we get x is greater than or equal to a negative 3. So we'll start by writing some numbers on our number line. I'll graph my blue inequality first. X is strictly less than 2. Now I'll graph my red inequality. X is greater than or equal to negative 3. Now for and inequalities, I want what is covered by a red and a blue line. So I'll go ahead and mark that in green. So this is both blue and red, all the way up to here, not including 2, because 2 is only covered with red. So if we were to write this in interval notation, x can go as little as negative 3 and can include negative 3, so it gets a hard bracket, goes up to 2 with a soft bracket. Let's look at our next example. There are a couple of ways we could approach this one, but the way I'm going to do it is instead of distributing that 3, I'm going to divide both sides by 3. So we get 2x plus 5 is less than or equal to 6. Subtract 5 from both sides. 2x is less than or equal to 1. Divide both sides by 2. X is less than or equal to 1/2. Let's use a similar approach on the next equation. I'm going to divide both sides by 2 instead of distributing. I get x minus 7 is less than 3, negative 3. Add 7 to both sides. We get x is less than 4. I'll write some numbers on my number line. Then I will go ahead and graph x is less than or equal to 1/2. Next, I will graph x is strictly less than 4. Now, what is covered by both blue and red lines? The 1/2 is covered, and anything less. So the solution to this compound inequality is going to be a soft bracket negative infinity up to 1/2. Oh, sorry, that should be a hard bracket on that 1/2. Let's look at our third example. 1/3 x minus 4 is greater than or equal to negative 2. I will start by adding 4 to both sides. Then multiply both sides by 3. Now let's look at our other one. Again, instead of distributing, I'm going to divide both sides by a -2. We divide by a negative number, so we have to flip the sign. Add 3 to both sides, and we get x is less than or equal to 1. Write some numbers on here real quick. So x is greater than or equal to 6. So we can do a solid dot, and it's greater than. X is less than or equal to 1. Solid dot on 1, and less than. So where's our overlap? There is none. Because there's no overlap, there is no solution. There is no solution in which both of those statements are true at the same time.